All right. Do a little distributing. 3 times x. Got variables on both sides, so we'll get rid of one of them. Positive 3, subtract 3. Whatever I do to one side, I do to the other. All right, that cancels. 6 comes down. Equal sign. What? 3? That cancels 2? 6 equals 4. That doesn't look right. What happened? Hey everybody, it's Wojo, and today we're looking at what we call special cases. So when we look at that problem I was just working on, it looks like maybe I screwed up, but instead it's not that I screwed up, it just happens to be one of our special cases. So today we're going to look at no solutions and infinite solutions, what it means, and how to tell when you run into them. Alright, so there are two types of special cases when we talk about solving linear equations. That is no solutions and infinite solutions. So these are the strange things that happen when you're solving. At least it seems strange when you're going, because sometimes it's hard to tell if it's no solution or infinite solution before you start. But basically what happens is all the variables cancel out. And one of two things is going to happen when the variables cancel out. You're going to be left with a statement that's either true or false. So if you end up and all the x's cancel and you end up with something like I did where it says 6 equals 4, which we know is not true, then we're going to say there's no solution. There is not an x value that exists in the world that we could plug into that equation and it would work out. And so that's what happened in the first case, in that all of my x's canceled. I was left with something that was false. When that happens, we would say no solution. If instead when all the x's canceled and I was left with a true statement, like let's say 3 equals 3, where that is true, that means that any real number we can think of, so you can think of any number that's a real number and it will make it work. So basically any number works, and so there's an infinite amount of solutions. So when we're solving, there's really 3 types of answers we could expect if we're solving linears. We could expect just one answer, like x equals 5. We could expect no solutions, or we could expect an infinite amount of solutions. And that's important to know when you're solving. So let's go back and look at the problems, and I'll show you what an infinite solution looks like, and then we'll let you guys see if you can tell some on your own. All right, so we're back at the problem we started with, the one that I thought I had made a mistake on, but I did distribute correctly. Remember, our first step, if we see parentheses, is to multiply that out. I noticed there were variables on both sides, so I undid one side, so I subtracted 3x. But there was 3x's on each side, so when I subtracted them, they canceled, and I was left with 6 equals 4, which is a false statement. And so then the answer that I would put down if someone asked me to solve this is I would simply state, well, you might want an answer, but this problem itself has no solutions. Now, you could also have one where it worked, like with the ones we've been doing, or you could have one that has an infinite amount of solutions. So let's take a look at a second example, one that would have maybe an infinite amount of solutions. Now as I'm writing this out, see if you think you could figure out if it had infinite amount of solutions before you even started. So if I said 4 times the quantity x plus 2 equaled 3x plus 8 plus x. Now, when you see a problem like this, you would have to just start solving it just like normal. You probably wouldn't see it as a special case. And so you would start. I would notice that I have parentheses here. Parentheses I know mean multiply. Because there's more than one thing in the parentheses, I know I have to distribute or multiply that out. So I would start and I would multiply that out and get 4 times x is 4x. 4 times 2 is 8. Move on, get my equal sign over here, and then I would have an option. I could just rewrite this whole thing, or I could look at this side. And notice on this side, I have an x here and an x here, and those x's are on what we call the same side of the equal sign. And so we learned that if they're on the same side, we combine those two x's together. So if I had 3 x's, I just picture myself having 3 x's like an alphabet soup, and I added an x to it, then altogether I would have 4 x's. So we could just combine that 3x plus x to give myself a 4x, and then I could just bring down that plus 8. Now at this point you would probably be able to recognize we're running into an infinite solution, an all real number solution, because the left side is exactly the same as the right side. And so remember, infinite solutions means anything would work. So if I picked x plus, let's say x equals 1, is 4 times 1 plus 8 going to be the same as 4 times 1 plus 8? Sure, so x equals 1 would work. X equals 2 would work because 4 times 2 plus 8 is the same as 4 times 2 plus 8. No matter what x value I would pick, it would work. And so that's where the infinite solutions, all real numbers, comes from. If I wanted to keep solving this, I would notice I have x's on both sides. And if you remember, when there's both sides, x's on both sides, we have to get rid of one of them. And so let's say I want to get rid of a positive 4x. Well, to get rid of a positive 4x, I just subtract 4x. Whatever I do to one side, I do to the other. And this is where all the x's would cancel out. 4x minus 4x is nothing, and it gives me 8 equals, x's cancel out again, and equals 8. Here, everything canceled out, but this time it's a true statement, whereas the first time I did it, it was a false statement. If that happens and all the x's cancel out and it asks me to solve, then I can say my answer is all real numbers. Any number would work, so a lot of times they would say all real numbers. And sometimes they would say, well, there's an infinite amount of answers. Saying there's an infinite solutions doesn't tell you what the answers are, but it gives you a pretty good idea that almost anything would work. So you see kind of both things used, although all real numbers would probably be the more technical right answer, meaning any number would work. So we have two types of special cases. You're going to solve just like normal, and then when you get to the end, if all the x's cancel, you're looking to decide, is it true or is it false? If it's false, then we say no solutions. If it's true, we say there's an infinite amount of solutions that any real number would work. Now don't forget though, we still have our normal solving, our most basic solving, like something like 2x plus 4 equals 8. This one has a solution. So you can have no solutions, you can have infinite solutions, and don't forget, you can have one solution. So our normal two-step problems and things, sometimes the x's don't cancel out. Sometimes you're going to be left with an x. And in that case, there's one right answer. The one right answer is whatever the x value you find is. So you can have just one solution as well. So, one solution, no solutions, or infinite solutions. But this just adds kind of another trick to your bag of solving tricks. And hopefully if you run into this case, you'll know what it means now. If you guys have any questions, as always, let us know. We'll be more than happy to help.